What is actuator control for robots using neural networks? Imagine a robot moving smoothly and precisely, almost like it has a brain of its own. That's where neural networks come into play in controlling robot movements. Actuator control in robots is about managing the motors or muscles that make the robot move. These parts convert signals into physical actions, like lifting an arm or gripping an object. Getting these movements just right is key for robots to perform tasks effectively. Traditional control methods, like proportional integral derivative controllers, use fixed formulas to send commands to actuators. But these methods can struggle when the robot faces complex or unpredictable environments. Neural networks, inspired by how our brains work, can learn from data and adapt. They don't need detailed mathematical models of the robot's behavior. Instead, they learn the relationship between what we want the robot to do and what the actuators need to do to make it happen. For example, a neural network can learn how a soft robotic arm bends and responds to different forces, even if it's hard to describe mathematically. There are different ways to use neural networks for actuator control. One method is model-based neural control, where the neural network learns the robot's dynamics and helps predict the best commands. This is useful for complex systems like soft robots or robots with nonlinear behaviors. Another approach is direct neural control, where the neural network takes sensor inputs and outputs commands directly, adjusting in real time. This method is great for robots that need to react quickly to changing conditions. Sometimes, combining traditional control with neural networks creates hybrid systems. Neural networks can tune the parameters of classic controllers or compensate for uncertainties, making the robot more responsive. The benefits of using neural networks in actuator control are impressive. They can handle nonlinear behaviors and external disturbances better than traditional methods. Neural networks can also adapt to changes in the robot or environment, making the robot more flexible. They improve movement accuracy, reducing errors and overshoot, which results in smoother, more precise actions. In practical terms, neural network controllers are used in robotic arms to solve inverse kinematics, which means figuring out how to move the joints to reach a target. Soft robots, which have flexible and squishy parts, relying heavily on neural networks to learn their complex behaviors. Neural networks also improve torque control, helping robotic arms follow precise paths by understanding how forces and movements relate over time. Some advanced neural networks even use visual data to control robots. They analyze camera images to estimate how to move actuators, allowing robots to respond to their surroundings visually. Overall, neural networks in actuator control give robots the ability to learn, adapt, and perform with greater finesse. They help robots move more accurately and reliably, especially in situations where traditional control methods fall short. As neural network technology advances, their role in robotics will only grow, making robots smarter and more capable in emerging fields.